refer to the equation f of x equals x squared plus 6x plus 7. Part A asks us to determine the number of real solutions of x squared plus 6x plus 7 equals 0 by looking at the graph. So we're looking for how many times our graph will cross the x-axis. Let's take a look at our graph and count how many times our smooth curve crosses the x-axis. Notice it crosses one point here. Here's our x-axis. And it also crosses here. So there are 2 real solutions. Part B asks us to use the quadratic formula to find the exact values of the real solutions and give the solution set. So we're going to need the quadratic formula, so let's go ahead and get that presented here. X equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Notice that this division bar goes all the way to underneath the minus b. Don't stop at the end of the radical. Now we need the coefficients labeled in our original equation so that we can substitute them in properly into our quadratic formula. So our original equation is f of x equals x squared plus 6x plus 7. So we need to label these properly. Our coefficient of our x squared term is labeled a. The coefficient of the x term is labeled b. And the coefficient of our constant, well actually our constant, is labeled c. So now we're ready to find the exact solutions, these real solutions, using our quadratic formula. Okay, let's relabel a, b, and c. And let's plug in to our formula. X equals opposite of b. b is a positive 6, so it becomes a negative 6. Plus or minus square root of b squared. b is 6, and we'll square that. We'll clean that up in a minute. Minus 4 times a. a is the coefficient of x squared, which is 1, times c, which is 7. All divided by 2a, and a being the value 1. So let's continue simplifying. Negative 6 plus or minus square root. 6 squared is 36. Minus 4 times 1 times 7, which is 28. All divided by 2. Negative 6 plus or minus square root 36 minus 28 is 8. All divided by 2. We're going to rewrite this in a simpler form by simplifying the square root of 8. We could come off to the side and break up square root of 8 into square root of 4 times square root of 2. Simplifying square root of 4, we have 2 times the square root of 2. So we're going to use that as a substitution for square root of 8. So we have our minus 6 plus or minus. We're going to transform or substitute this 2, the simplified version, 2 square root of 2 divided by 2. We're going to see if we can simplify a little more. We're going to try and factor our numerator, noticing that there is a common factor between our first term, negative 6, and our second term, 2 square root of 2. And that common factor is 2. We're going to pull our common factor out to the front, and we're left with a minus 3 plus or minus square root of 2 divided by 2. Notice now, our 2's are factors. They can be divided out. So our exact solutions can be represented by x equals -3 plus square root of 2 and x equals -3 minus square root of 2. And our solution set can be written as -3 plus or minus square root of 2 in our solution set brackets. Part C. Refer to the equation f of x equals x squared plus 6x plus 7. It says use a calculator to find approximations for the solutions and round your answers to the nearest thousandths. So we have our solutions listed as x equals -3 minus square root of 2 and x equals -3 plus square root of 2. So using our calculator, we can get approximations to the thousandth place. -3 minus square root of 2 is -4.414. X equals -3 plus square root of 2 can be approximated as -1.586. Again, notice we have gone to the thousandths place.